again. My name is Avkash, and in this video, I am bringing you the integration of maps with your mobile, web, or desktop applications. So if you are React developer, you love developing your front-end application in Chakra UI, this tutorial is for you. In this tutorial, we are going to use Chakra UI with ReactMapGL and DeckGL to build multi-layer, beautiful, inspiring map-based applications using React, DeckGL, and ReactMapGL. This tutorial also comes with the starter code. So everything what you are going to learn, you can also follow in the starter code, which is available at the GitHub repo. If you are new to mapping, integration with front-end, mobile, web, or desktop application, please visit my another tutorial where I have provided some of the general introduction level information about how you could integrate map services or mapping functionality into your front-end applications. Here we have our tutorial plan. We will be using Mapbox as our mapping service provider, and then using ReactMapGL library, which is the wrapper for the Mapbox GL, and combine our tutorial with DeckGL. The DeckGL is ready to work with either React or not React, but in this example, we will be using the DeckGL with ReactMapGL. Here we have our source code. It's available at public code repo at prod.ramp. And the folder is ReactMapGL DeckGL demo. At first, both map data demo final and the starter has the identical code. If you are using a starter code, you can follow the code in final and learn how the code is implemented. If you want to run the code by itself, then the complete code will be available in map data demo final, which you could use to run the whole tutorial at once. The starter code is there only if you would want to follow up the whole tutorial and walk through a step-by-step tutorial and implement in the map data demo starter code. In this tutorial, we will be using the map data demo final folder as our base folder to start our code implementation. Now we will be opening the final code in Visual Studio Code IDE, and this code is taken from one of my previous tutorial where I have used Chakra UI code and added various routes to it. So this code already has pre-built routes to use, such as home and data home, and these routes are all implemented in this components folder within the containers, pages, and partials. Now we will go map data demo final and install the packages using node package manager install. And after some time, when the installation will be done, we will run the npm start to start the node server and start working on our tutorial. So node server is started, and here we have two routes, index and data home. So we can see data home, and this is the data home, and the data home code implementation is here. So this is data home. So what we will do, we are going to add a new route called map home, and we will be integrating all the map specific code over there. So we have a map home. Let's add map home. Okay, so this is a route it's going to implement here. So this map home. Okay, now it's okay. Now the map home will be in pages data. So we will come here pages, and here is the data, and rather than data, we call this map folder. So pages, we will create folder is map. Implementation, we will create a folder called map, and the containers, we will create a folder called map. And in the pages, we had map. Here we are going to create the map home similar to data. Here is our mapHome.jsx. Sorry, it will be the JS, and similar to data home, it will be map. So we have map home here, which is going to connect to the container map home, and here will be our map home ex, and it's going to connect to this component. So this map home is going to connect here. So we need to create the container map home ex now. So container, we are here in container map home ex.js, and it will have data similar to here. So we are in map home, and it's returning this, and it's connected here, and it's gonna be map. Okay, now implementation map, we need here map home JSX similar to data home. Let's use this code here. Here is our map home. Let's see. So we are at map home, and index.ex. So let's see index, and here map home, and that's the map home. If now our route is added, so if we try to connect to map, here is our, we are at the map home. So here is our page, here is the implementation. So here will be our code where map specific visualization will be here. Now we are going to import the packages which are related with ReactMapGL and DeckGL. So in order to import those packages, first we need to add those packages in our package.json. So here is our package.json. So I will be just adding those packages directly. So let's use this and here. So we have added these packages, Mapbox GL, ReactMapGL, and the DeckGL, and then some of these, the DeckGL for React, DeckGL some layers component. So while we are implementing this code, we are creating the notes. So those notes will be available for everyone to try on this README file located at the same place where the full code is available. So we have, these are the okay. Once we have added this, now we need to install these packages. So you could have used npm install, but I will be using the install package manually. So here is our Chakra, and then we have React, and then we have map final. Here is our, okay. So npm install. So calling npm install will download those packages which we have just added into the package.json, and they will be accessible in our code. Now it's the time for us to integrate the Mapbox access token in our project. So to add that project, we are going to create the .env file. That's where we are going to store our access token. So I will be creating the new file at the root .env. So that's where the location is. And after that, I will create this variable equals, and my token is this. That's my token. So React app Mapbox token is stored here. Now what we can do is that we could access this token as a variable. So we need to create a location where all our constants related with project is stored. So we have utils. I will create a file called constants.js here, and I will define a new variable which will be the Mapbox token. So Mapbox token equals, and then this token should be reading the token available at env. So we need to read this thing, and here is the code. So as you see here that we are exporting this Mapbox token, calling process.env, and read this token, which is this token. So this here, if it is not available, then make this Mapbox token is an empty string. So now wherever we want to access the maps, we need to supply this token, and we will be using this variable as the token variable. Close this, next. So we have integrated our access token. Next, we need to add the Mapbox widgets where all these maps related code will be there. So in this map folder, I will create a new folder called widgets, and that's the place where we will implement all the map related code at one place. So I will be creating a new ReactMapGL component here, file React widgets, new file reactmapgl.jsx, and I will be just walking you through piece by piece. So first 3 lines here, as you can see that we are importing these packages from React, then from Chakra UI, and from ReactMapGL, because in the first step we just want to use the ReactMapGL library to build the map. So that's we are covering here. So we have got that thing covered. Next, we need our Mapbox token. So we can say import instance. So Mapbox token is integrated. Next, I will be using this code, and I will just giving you explanation of this code. So here we are creating a function ReactMapGL view, and as you see here we are calling ReactMapGL. Mapbox token is used, Mapbox API access token, map style. We need to look into the different styles which are available from the React Map GL library. There are several styles available. We are just using the Streets version 9. Height, width, viewport is exactly this. So we are setting when this map is going to start, it will have a location, latitude and longitude, that will be the viewport, and then the zoom level will be 19. So you can experiment from zoom level 1, zoom level 30, and how everything look like in your map view. And here is the event on viewport change. The new port is going to updated with a new viewport. So we have added this ReactMapGL. Now we need to call this ReactMapGL view in our Mapbox home. We copy it, come here, and we are going to import it here. Import from, and that should be in our same location. So because we are here, so it should be one level inside, and that should be widgets mapgl. And this is the component we will be opening here. So here is a box. Width is 100%. As this component, and try to render here. So this is our Chakra UI page. Let's reload. So in this very first example, we have implemented this ReactMapGL component here, and very simple using map style and initial viewport where the longitude and latitude along with the zoom level, that what you are seeing here. If we change this to zoom level 1, you are going to see here how this application is going to zoom here. As you see that we are all the way to the global map. If we say zoom level 30, you will see that zoom level is going to be at the almost, it should be where this component is already zoomed very deep. As you could see here, it was almost at this level. So zoom level 30. So the suggested point is that if you are looking into zoom where you are at the street or building level, you could use zoom level 20, and that's where you are. So we learn this part at this point using ReactMapGL. Now we will go one more level up and try to use the DeckGL. So again, we will be creating the component all in visits area, and then once component is ready, we will call that component here and access it here. So if you are interested into DeckGL, I would suggest you to look into this developer guide. There is so much information available, API references, and then depending on what kind of application you would want to try, the example section is very good. Here these various examples are there. So for example, this is the Heatmap layer. It shows how you could build the heat map. Let me make it full screen. So for example, if you are interested into heat map, here is the whole application, and here is the code related with heat map, and you can take a look how to integrate. Look into another example here. We can look into the icon layer. Here you can get how these icons are added. Again, code will be very helpful for you. If you are looking into the scatter plot, here is your scatter plot. If you are interested into the hexagon, here you can see. So sample code is available for you to check and implement as you want. So I will be taking some of these examples which are available here, and I will be implementing in our Chakra UI project. In this next step, we are going to build the new map using DeckGL. So let's create a very simple component. We call it DeckGL map.jsx. So here is our component, and in this component we are going to use this heat map example, and we are going to implement this heat map. How we are going to do is that we are going to use ReactMapGL and DeckGL combined here. First thing, you see we need DeckGL, and there is the DeckGL, and we need StaticMap, which are part of ReactMapGL. And you will see how we are trying to create these hierarchical components. In this next step, we are going to create the component. So it is export default DeckGL map. So this is a GL map. There you go. And here we are returning, and here this DeckGL will be used. So as you could see here, there will be DeckGL, and inside this DeckGL there will be StaticMap. This is how. So the definition related with all the parameters related with this function will be passed here, and any other function needed here, and this will be the render. So let's try to feed the information needed for it. And here in our example, we are going to create the heat map. So we will be using Heatmap Layer. So based on this example, we are going to feed the data. So let me see the view code. Here is the code related with this application. So we need this data URL, and we need initial view state. So we have used data URL, and here is the data. If you are interested into data, here you can see this data is a combination of longitude and latitude. So that's all we have here, and this is our demo, and here is the code, and we have initial view, and these are the initial view state parameters. Then I will be using this code, and I will let me replace this, and now you get an idea. So DeckGL has initial view, controller, and it's needed layers, and then static map, going to use map style, and that's where our code is. Okay, now is, as you see here, that need a map style. So here is the map style, and map style is used by StaticMap, and these are just different prevent style diffing true. Map is going to be reused, and now controller is true. Initial view state we already set. This is our initial view state, and now layers. So layers needs to be added now here. So let me add this layer here, and that is basically these are the layer. So we are creating layer array, and new Heatmap layer is here, and it needs data. Data will be fed into here. So that's first time the data will be data URL in this one. So that will be data ID Heatmap layer. So you can call it anything. Custom Heatmap layer, pickable get position. In this data, all that values which we are using here, take and itemize them D0 and D1. So remember, we have seen that data. One more time I will be opening you. So here you could see this is the D0 and D1 for every row. So that's our data, and that's the weight for the heat map, and that is the value of 0, 1 and 2. So heat map value is part of this value, heat map value. So depending on 1, 2, what the value will be, that's your heat map weight, and rest are the radius pixel intensity threshold. So we need to define them. So as you see here, intensity threshold pixels are defined here. So now we have saved this, and that's our DeckGL map component is added here. Let's take this component DeckGL map and import here. So import DeckGL map from widgets and DeckGL map, and we will call it here, and we will comment this one. Let's come here, reload this page, and you can see here that the heat map is here. Now we need to create this height width properly, because if you see here in this component, we might need to make that bigger. So one option we have in this box, we can say height is equal to 100 vertical height. And here you could see that our height is became vertical height, and width could be 100 vertical width or 100%. And that's where it is. So very quickly, this heat map demo which we were seeing here is actually available for us in our code. And that's how we implemented this DeckGL heat map here. Next, we can again take a look from this and say, okay, we would like to implement another example. Look into examples, and here we have some examples which we could use, and let's try to use this scattered plot. That would be interesting to see how we could really look into. So here is the code. So as you could see here, StaticMap DeckGL, same composition as the only difference is that we are adding here a scattered plot. So let's add a new scatter plot map dot component. That's our scattered plot. In this scenario, I will be just copying this all the way up to here. I will call it scatter plot map, and here are the layers. So let's see. Controller, the static map reuse is almost identical, as you could see here. So only difference here is in layer and then a starting point. So in this scenario, the starting point is this data. We can take a look in the scatter point. The data is again this Manhattan city data. So these are again the coordinates we have. View state is scattered plot. As you see here, data URL is this data is being passed. If you have data coming out from API, you can just call this static or state variable, depend on whatever you have. Radius, male versus female. So it means that in this data, the data is calculated here. If the D2 value is 1, make the male color, otherwise female color. So we can look into this data. You see there is a 1 and 2 value. It means depending on 1 and 2, 1 could be the male and second could be the female. So that's the fill color. Color is being filled, radius, and these are the date triggers, and that's pretty much. Now, very quickly, we could take this component, integrate with our main. So import from ScatterPlot map, ScatterPlot map as command this one. Here you go. Your scattered plot is exactly implemented here. If you want to change these colors, for example, you already have an idea. This is your male color and this is your female color. So just an example, if you want to convert the male color to yellow, you could say 200 and 200, make it maybe 5, and that's where the color. And then because more of this, but then female color, we could want to have green. We could say 255 1, and that's where. So you have green and blue. So if we just try to convert this 255, make it 2, 2. There you go. So the male and female, the way it is. If you want to change these radius for these balls, you could say radius is 130. You can see here radius is 1. It's quite not visible. Let's have a 5. At least there are some data points available. You just need to zoom in, then you will be able to find. If you have 10, there is, so you get an idea. So we have seen this layer. The difference between these two components are that one has the Heatmap layer, one has the ScatterMap, and as you could see here, these layers are coming from DeckGL layers. And let's take a look another example here, to examples, and see that can we implement these arc layers. So here are the arc layers. So let's take a look into this code. Here is the arc layer code. Let's implement the arc layer. I will close this. Let's add the arc layer map.jsx. I will be using this whole code. The definition is here: arc layer map. That's our arc layer map. Let's study. If you see here, these two are, we have already seen the layers. We are using the get.json layer and arc layer. Here is the JSON data. We can look into this data. So here the data is a little different. Here we have JSON data. There is a feature, has a type, and then within the properties there are these flows. Okay, and this is the centroid, and then these are the multi-polygon coordinates. So this is data is a little different. Then we look into the implementation part. So here we can see there is a DeckGL layers controller get tooltip. So now we have seen the tooltip implementation. The StaticMap is quite similar to before, nothing changed here. So we will not be learning anything new here. One important thing to remember is that when this component was created individual, the data is loaded. So if fetch data URL, it means this data is loaded, and once the response is received from this URL, that is converted into the JSON object, and from JSON the features are selected. So these features are being fed into this component as a data parameter. So we need to perform this whole code in our code if you are trying to use it. So we need to pass this data and the features here. So before we study it, let's implement that code here first. So import from widgets arc layer. So here we are using the arc layer, and here we need to provide the data equals. Now we need to set up a local variable where we need to pass this data. So we can say this dot state dot arc points. So that's our data. Now you might ask how this arc point will be there. So let's add the state. So state slash, so we have arc point. Now when this component did mount, we need to fetch this data. So the activity for us to fetch this here, we need to fetch this data URL, and we need to perform exact same thing here. So it means we need to take this code here, we say let's fetch it. Okay, and here if features, we need to say this will be feature. So this will be set state and arc points equals features. Okay, so and now we need data URL. So data URL is this. So let's arc points will be fed into here. So now we need to, so this is the arc layer. Let's see. And there you go. So we have fetched this data, features, we pass into there in component mount when we are using, and then that's how your arc layers are added into your code. And one thing to remember now, you see that this map is a little tilted here, and that is coming because of these new settings here in your initial view state. So here you could see that there is a pitch and there is a bearing. So that pitch and bearing is what is changing. So if we do not define pitch and bearing here and reload it, you could see we have changed this view little different now. And if we add this bearing too, that's how you could see the map much. And if you try to zoom in, you will see that we have a way that when we try to zoom, we are actually going inside these arcs. So we have implemented arc, and if we try to look into the code, we can understand there is a layer array. It has GeoJSON layer and arc layer. And in GeoJSON, if you see here, there is the data is being fed, and it's looking into the select county object. So we need to look into how the county object is being calculated. So here we can see in this data, because this is the JSON data, and here is the properties, select county. So if you see here, select county is this fit into user state null nothing, selected county. So calculate arc. So data and then the selected county here. So calculate arcs, not look into what is calculate arcs. Here is the calculate arcs. So here you could see that property name is selected county. This is how, if it is null, then you need to find if the property name is Los Angeles. So what they are trying to do is that they are trying to look all these county related with Los Angeles. If you want to change this to something different, so arcs will change. So in this scenario, let's change this to San Bernardino, and the data points will change for us. Let's take this, paste it, take this LA here, save this, come back and reload. There is a definitely change. Now it's no longer the LA, it's became the San Bernardino. So this list of these arcs which are being calculated based on which county you would want to select from your source data. Text layer in our project, text layer map.jsx. Here is the text layer map, and quite similar to this. The only big difference is that we are importing a text layer. Could be anything. Is ID data. Let's take a look into the data. Here is the hashtags, 10 hashtag, label, which coordinate, and the weight are given to it. So coordinates has the value and the label. So as you could see here, position for that hashtag where it should come is on this area, and then the value should be printed as a D label. Size, here is the font size and scale, and the color is defined here. So RG is almost yellowish RG, red plus green. So let's save this, and we have text layer map. text. Let's use this text layer here. Let's comment this, save. Let me close these tabs. We do not need these. And here is our text. This is quite a big font. We could change these text layers to text. If we want to make this font smaller, we could call it 2. Here is the text, and if we try to zoom in, we would be able to read the text better. Until then, we will just see some haze. See here, so it's a little better visualization, as thus you can get an idea. If we go back, this is how the density look like. Now, in our next step, we are trying to compose a new example by combining 2 or more layers. So first we need to create an application which has 2 different layers, and then we try to combine it together. So let's look into an example where we are trying to combine the text and layer together. So we have already seen the text layer map. Now we try to combine the text and a scattered map together. So let's create a new component, text ScatterPlot map.jsx. So here we are combining the text and scatter plot together. Okay. So we have already seen this scatter plot example where we had this Manhattan data. So here you see this is a scatter plot. So what we will do, we will take this scattered plot data and we will put into the text plot. So now we have scattered plot. Then if you see here, this is the Manhattan data. Now we are going to use this data and we try to change this data URL to something else where we can get text and we can get the coordinates together. So we could have 2 layers, scattered plot, text plus coordinates. So let's find one of the examples. So we have here, so in the scatter plot we have Manhattan data, and if we look into the scattered plot, text plot, we have the metros data. Let's take a look at example here. Samples. Icon layer. Metroids landing. Let's look into this data set. Here you could see that in this metroids data, let me show you this. Here we see we have a coordinate, we have the mass. What is this metroid mass? So let's try to have the text where we will print the either name or the class of that metroid and then which coordinate it is, and then we will try to enhance that by creating heat map for this mass. So we will be combining this data. Okay, so here if we are looking into this scattered plot, there is no male and female. We don't really need this. We don't really need these triggers. We can log them. Now if you look into here, it says d.coordinates. So we need to get this exact same coordinates, d.coordinates, and this fill color for the scatter plot, we need the plot color. So we need to make sure everything is, so plot color, let's define the plot color. That's, so we have text, scatter, plot map, that's our component. This reads the data URL. Let's come to here. Import from widgets text scatter plot. You need to see this. Some of these maps are created here, as you could see here, but these values are very small, so we need to zoom out our map depending on this view, because this is what the data we are using. So this data, as you could see here, is the map view. So we could look into what the initial view settings are, and we can replicate that. We could use this initial view. Now you could see here that now we just really need to make these points a little bigger. So get radius, make them 100, so they would be bigger, and they look like, okay, let's save this and reload. Here are the data points. So the radius scale, radius, and this radius scale is this. So we can say radius scale, use here and then make it 200, because that's get radius, then 200. At least now we could see that these data points are, so these are for the falling meteors. Now we are getting to make it little more visible. Let's make it at least more bigger, and now we have more clarity about. Now we want to add the text layer here. So for example, if we zoom into, we want to see the text layer too. So now we are going to add one text layer here. We don't need these codes, so we are going to remove this, and add one text layer to it. So let's go look into our text layer code. Here is the new text layer. So here is the layer is array. So new, we need to add another item in this array. So we have text layer. We just call it make total location. And now we need to look into in the data set, the location, we call it a name. So it should be d.name. And it should be d.coordinates. So that's coordinates is there. Default color is this. Get size, or we don't need to pass this because that's should be okay. So now the text location, and it must be name, and that should update the text along with. So text layer is not defined, so we need to add this text layer. Next, we need to add the default color and font size. So here we can add the font size is 12, and the default color we can just give it. Default color is this. So default color, let's make it RGB. So R. So now in this example, we have combined the two layers. I would want it to have a little more black would be okay. So I could just make black. At least we could see. My point is that at least we have seen. Now, what we need next is to, in this data frame, we have coordinate, we have class. Now, what if we try to use this mass and try to create a vertical, like a 3D view of mass? If lower mass, lower bar, or if the higher mass, the taller bar, how we could do it. So let's see one example we have here, and then we try to replicate it here. So example is this hexagon layer. So this, in this example, as you could see here, these are the different hexagon, and depending on the density, these hexagons are created. So we will be using this logic to build the hexagon layer. So we are going to combine the text scatter plot mixed with hexagon. 6. I do have one example for Hexmap, so we will look into that. So here you could see here we are reading this data, Heatmap data, and that is red, and here we are creating new hexagon layer, elevation scale as you could see here, and this is the hexagon layer. So this is our hex map. First see its view, then we can implement it. Import hex map from widgets, hex map, and for this hex map, as you could see here, this is the data. Here you see this is a CSV format data. So now we have to read this data and we have to process it so we could fed that data into the JSON format. So we have to make all that work here, and in this example, again, it's reading the CSV and then processing it. So we have to make sure that this data is fed into in this hex map as the data object. So mapHome, whenever we are trying to call this hex map here, hex map data equals this dot, this date dot, hex points. So we need to define the hex point here. Okay, Let's block this for a while. Now we have to create the another fetch code. Fetch hex point, and let's read the data related with Manhattan. So we are reading this Manhattan JSON data, is storing into the hex point. Hex points will be in Hexmap data, and then Hexmap will be rendered here. Data. So hex point will be stored here, data. And as you could see here, these are the values which are added based on Manhattan data. So we can look into what this data look like. So here you could see that this is a similar data which we wanted to show. So here are all the values, coordinates in Manhattan, and we are combining these values in a way. So depending on the number of items in that particular coordinate density, that bar will be taller and taller. So that's all that you could get based on Manhattan data. That's one example we are using in the Hexmap. If you are interested to learn more about Hexagon layer, here you could see that this is color range. D means data is here. Elevation scale is using the data length, elevation range and percentile, and then elevation scale is 1000. So, and rest is quite simple. Tooltip is built into here. As you could see here, when I'm using my mouse, it's telling me what is the longitude, latitude, and how many accidents total. So that density is 7. Here you could see that 8, 10. So the number of items in that longitude and latitude density. Here blue is like a 2. And that tooltip is implemented here. And if you are interested, you can look into the code. So the tooltip is added here in the deck.gl component. Now we need to use this code and add this code in our text scatter plot, where we would want to add the hex also into it. So we will create a new component called the text, hex, and scatter plot. Create a new component, text, hex, scatterplot.jsx, and here we will take this whole code, we will drop here, and then we will also add the hex layer top of it. So we have got that, and here we are using the methods example. So we call it text hex scatterplot, text hex scatterplot. So import from text hex scatterplot. So we got that way. Now because we want to show this angle, so we are going to use this hex map bearing and pitch. We got that here. Now you see this became, so if we are trying to show those bar, they will be more clear to us. Now hex map, let's bring this new hexagon layer and new text layer, scatter. Okay, now we are adding new hexagon layer. So this is the hexagon layer, and now is hexagon layer is not defined, so we need to go look into hexagon layer is actually part of the aggregation layer, so it has to be added separately. It's not part of layers. So we have got hexagon layer. Now we need color range, coverage, upper percentile, and material. So we can look into this because most of the definitions are there. So we need material value. So here is the material. Then we need color range and coverage. So here is the color range. coverage and upper percentile. So coverage and upper percentile is basically here, I think, yeah, part of. So here is our get positions. So let's see how our data look like. So we have coordinates. So it means that we have to actually coordinate defined clearly here. So in this case, the coordinates will be these. We don't need this, but we need 0 and 1. So that's the coordinate. The elevation range we need in a way where we could elevation scale. So elevation scale, let's make 3000 at the range from 100 to 3000, and elevation scale, so let's call it elevation scale is 3000. We do not need this value. Let's put radius is 5000, because that way at least we will see the data first. There you go. Some changes start coming now, because there you go. So now, as you could see here, that our elevation has to be changed to the value, but at least we have all three things. Get elevation value. So what is the elevation value? Elevation scale, there is no. So let me see if they have get elevation value, and that should be the number. And if it's the number, then it will be the D, and from the D we need to use d.mass, because that is part of the metro data set. This is the mass. So this mass has to be converted into the number, because this looks like a string here. So we have done that way. So if that's the value here, so looks like in here the method was really very big. Because of this number is really very big, they have the other heights are kind of messed up, because now they are not really that much resolution because of one very large big outlier. If we remove that value, and we will be able to see more variation in these values. Otherwise, if they are smaller, we are just trying to hit into the lower range. But the objective, we had to build this 3-layer demonstration, and it's working for us. So if we look into our code, we can see that we have built these various about 1, 2, 3, 4, 5, 6, 7, 8 different maps, and all these maps are related with MapGL and the DeckGL. And in this example, we have seen that how these maps can be integrated with our Chakra UI code. Now let's push this code to our server. So we have status. Everything should be the code you can look into. So the code related with our project is available in this map data demo final. You can look into the SRC component implementations, and here is the map, and all those widgets are added here. So if you would want to try this code, feel free to clone this repo and use this starter package to get it done, or run this whole code directly by accessing this map data demo final code. So that's all I had in this tutorial for you, and I will be seeing you in my another tutorial. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.